analysis, it basically relies on equations and simulations like FEM, right? So these methods are accurate, but they are time consuming and they may not capture complex real world behaviors, right? So this is the limitations that we have in the traditional methods. Now, let us understand first what is machine learning. Okay. So, machine learning is actually a technique where system learn patterns from data and makes predictions. So instead of explicitly programming rules, we allow the system to learn from the examples. And these are the different types of machine learning algorithms or machine learning that we have. So we have supervised learning, unsupervised learning, and the third type is reinforcement learning. Now, what is basically supervised learning is that um, uh, with the data, we also have the classes or the output along with the data. So we train the machine by giving that data as input. So the machine understands that, okay, these are the input features and there is one column which is actually the predicted output also. So the machine learns from that. And then when we only give the input features to the machine, it then predicts the output. So that is supervised. That means it is learning, when we are giving the output also to it. It is learning first and then we are asking the machine to predict, right? Now, the second type, that is unsupervised learning. Here, what happens is we don't give the output to the machine. We just give the input, it understands the pattern, and then it can predict. When we give some future input, it can predict. Fine. And then the third type is reinforcement learning. Now, here also what happens is we basically we form some mathematical equations, we implement it, and it learns from the environment, like kids or we human beings. When if we want to learn cycle, then what we do is we just sit in on the seat and we try cycling, pedaling, right? And we learn by ourselves, right? So no one gives you a set of rule, like you read a set of rules before learning to cycle. No one does that, right? So we learn by ourselves. So this reinforcement learning is the same thing. So let us move ahead. Now, these are some of the popular algorithms of machine learning: linear regression, random forest, SVM, neural networks. There are many, but these are some common. So this is the actual workflow of machine learning. So we have some data with us, right? Then we need to first pre-process the data. This step, the second step, is very, very important, because data can have many missing values. It may have, the data can be noisy, right? So we need to first pre-process the data, we need to clean the data, and then we need to give it to the machine for training, right? So when the machine is trained, and then we use again some set of input to test the machine, and then we deploy. So this is the actual workflow when we use a machine learning algorithm. Now, here in the case of structural engineering, what are the data sources, right? So, the common data sources, like from where we will get the data. So we can get the data from various sensors that may be, placed in bridges or buildings. So there may be some sensors that we can place. So the data can come from those sensors. Some lab experiments or some simulations that we do with FEM simulator. And we can also have some historical data. Now, there are some challenges also when we get that data from various sources. As I said, the data can be noisy. There can be some missing values. The data set can be too small, because if we, use machine learning, then we need a very large data. Large in the sense, if suppose if I talk about a CSV or Excel file, then minimum 1000 to 2000 rows we should have. This much amount of data we should have, and then only the machine can learn. Otherwise, if we have a very small data set, then it may give or predict the output which is wrong, right? And the data can also be imbalanced. Now here, I'll give you a very small example of what is the meaning of this imbalanced data. Like, suppose if I have a row, or if I have a column in my data, which consists of marks of students, for example, right? And the total marks are 100, right? The highest marks that a student can get is 100, right? So if suppose someone is entering the data in that Excel sheet, and by mistake, instead of 100, it is written 110 or 1000, so it is a human error, right? We have entered it wrong, but then that data contains that value, and which is a wrong value, and we cannot give such value, such input to the machine for learning, right? So we need to check the data thoroughly, that all the values in every column are within the range. Okay. So and there may be some missing values also. So we have different, data analysis libraries in Python also, that are used to handle all these cases. Like if there are missing values in a particular column which consist of our integers, then what we usually do is we place a mean value there, or we place some minimum or maximum value, and we don't keep that particular cell empty. Another approach to handle this missing value is that, if we have a large amount of data, maybe 5000 lines, rows we have in the data, then what we can do is we can just delete those rows that have missing values, and if the rows are very less, then it is okay if we delete it. Otherwise, then we need to think, we need to experiment also, that if we fill the missing value as average value, then what is the outcome, or what happens, is the machine trained properly? Or if we give maximum value in that column as the missing value, then what happens? So we need to do some experiments. So these are the basically challenges that we can face when we get data from various sources. Like we get data from sensors in the case of structural engineering. So from the sensors we usually get signals, right? And if there is a problem in the sensor, there's some glitch, then that signal also is it won't give a correct output, it can give some peak or something. So that is also the thing that we need to check. So these are some applications where machine learning can be used. So structural health monitoring. Here we can use machine learning for detecting cracks. For example, if there is a crack in the structure, then this will also take us example of this, and practically we'll see how it is predicting this. We'll implement this thing. Then earthquake engineering, this is also one of the application. Then design optimization. So in design optimization, we can reduce the material cost, or we can try improving the performance of the structure. So now let us move on with this case study, or we just see the practical implementation of how the we can predict the concrete strength. Yeah, so as you might all know, how do we predict the concrete strength? So this is the traditional approach that we use, right? So this is what water to cement ratio, that decides the strength of the concrete. Not only depends on water, right, and cement. There are many other materials also that are added to the cement, and then the strength of the cement depends on that also. So we cannot just say that just water and cement. Yes, water is a major plays a major role, but there are other parameters also that are used for measuring the strength of the concrete. So in this is the machine learning approach to this, that we have data. So it's a data driven approach. It learns from the patterns from the data, and then it improves the prediction. Now, these are the input parameters that we'll be using. So we'll have cement, water. We also have fly ash and silica fume in the cement. So the proportion of this fly ash and silica also, um, it affects the strength of the concrete. So let us move to the Python program. So see, this is the entire code that I have brought for you all. Um, Python, maybe you might not be familiar with this Python language, but it is very easy to use. These are like these few lines at the top, import statements that I've written here. These are basically different libraries that are available in Python, say like pandas, NumPy, Matplotlib. So these are various libraries that we can use. Now, what are libraries here? Libraries means it contains different types of functions and methods that we can easily use. So all the calculations and small things we need not perform by ourselves. We just call the function that are there in these libraries, and we can use. And then this we need for machine learning, right? And then this here what we are doing is, this is the URL where we have this CSV file, okay, from where we are reading the data. And this is the variable where we are storing this address, okay. And then this pd dot read csv, it reads that file and it copies it to a variable named as data here, right? And then we try to print the shape here is the size of the data. So you can see that this shape is printed as 1030 comma 9. So this means that there are 1030 rows in the file, in the data, and there are 9 columns. So, and what we have done is we have printed the first 5 rows of the data. So this head function, it prints the first 5 rows, because as you have seen that there are so many rows here in the entire file. So we are just printing few rows to check what are the columns in the file, right? So you can see there are 9 columns, and these are the names of the all the columns. So in machine learning, what we do is we call these columns as features. So these are the input features, and this last is the strength. So we are actually using machine learning here to predict the strength, okay. So this last column here, strength, is basically the output that we want. So first what we will do, since we are using supervised learning here, we will use all these features. We'll also use this output feature also to train the model. And then after the model is trained, we will only give these 8 features as input, and it will predict this strength, this ninth one. Okay, so let us move ahead. So now here what we are doing is we are just relabeling the columns. Okay, so here you can see that the name of this third column was ash, and we have relabeled it to fly ash using this method. And when we are printing it, you can see we have just changed the name. So we are changing the name of the column for our understanding. Now, what we'll do is we'll compare the results of the traditional approach and the machine learning approach, right? So now, what is the traditional approach here? So traditional approach, in this, what we are doing is we are calculating the water to cement ratio. So this is how we can calculate the water and cement ratio. And, then we are adding this water to cement ratio in our data. So in this data we have a column for cement, we have a column for water, but we don't have a column which gives the ratio. So we have calculated that, and we are adding one column to our data, which is this WC underscore ratio. So this column is added. Now what we are doing here is, for the training part, because we are using a traditional approach here, so what we are doing here, we are taking only this ratio, okay, as a feature. So this is the this is that x value, the feature that we'll use for training, because we are using only that ratio for training. And this y will contain the strength value. So we are just checking that, if the water to ratio is this, then the strength is this. That means the strength is dependent on only the water to cement ratio. Fine over here. Now in this particular line, what we are doing, we are basically splitting our data. So this test size 0.2 means we are basically dividing our data, as 80% data we'll take for, or we'll keep for training, and 20% of the data we'll keep for testing part, right? So you can see there are these four variables that are given here, right? And this is the function that is called, that is train test split. And what it does is, it splits the entire data and it is loaded here. So this is x train, so this is the input value x, while we are training, right? And this y train is again the prediction or the output that we want, and we'll give this also as input to the machine so that it is trained. And then we have 20% of the data that will come here in this x test, and in y test we will have the strength part, the output part. Okay, so this function is just splitting the data. Then what we are doing here, we are using a linear regression model of machine learning. Now linear regression is why we are using this, because it is basically very simple, and the method that we are using here, that is the traditional method, has also very simple relationship. Like the input and output relationship is very simple. We have just water and cement ratio, and the output is the strength. So this is very simple relationship where we can get just a line, right? So that is why we are using linear regression here. And this model, we are calling this model, and then we are asking the model to fit, or this is basically, this line is used for training the model. So you can see these two parameters are given as input to the machine. So this x train and y train. So all the input feature, this x train contains the ratio, water to cement ratio, and this y train contains the strength, right? So the model will learn from these two parameters that we are giving here. And then we are, once the model is trained here, we are asking the model to predict. So when we are giving the input to this predict, you can see that we are giving this x test only for prediction, because we want the strength as the output or the predicted value from the model. And then we are catching that predicted value in this particular variable, right? So this model is predicting the strength now. Now just we want to check that, is our model trained properly, or how smart our model is, or how well the model explains the data. For that, what we have to do is, we calculate this R2 score. So here you can see that the R2 score is just 0.27. Okay, so this score, if it is near to 1, means the machine has, it is very a smart model, and it has learned it has learned better. But here, since we had only one input, that is the water to cement ratio only, and the machine has learned only through that, and that is why it is very weak, and it is only the R2 value is only 0.27, right? Now, this was the traditional method. Now, let us understand machine learning, where we use it. That takes the machine learning model, takes all the features as input. Now, I'll just repeat again. What are the features? Features means all these input columns are the features. Okay. So we take all these columns into consideration while we predict the strength. Okay. So in this code, what we are doing is we are again splitting the data into 80% and 20% test and train split. And then here, since we have many features, we are using random forest regression for for machine learning, and then we are training it, and again the model will predict. Now here we are again calculating the R2 score, and you can see what is the R2 score. The R2 score is 0.89. It is much better than we were using just one parameter, that is water to cement ratio, right? So when we compare the result, we here what we do is we calculate the errors. Now, what is this mean square errors? What happens is that the machine is trained and it predicts the value, right? So what we do is we match the predicted value and the actual value. So from here you will understand that, see, this y test t, this was what, from here you will understand this y test was what the test data that we had, and in y test the strength column is there. Fine. So that was the actual strength value that was given in the data, and this is y predict is the predicted value. So it will compare the difference between the actual value and the predicted value, and it will calculate this mean square error from that. So for this traditional approach also we are calculating the error. Also for the machine learning approach, where it takes all the features, we are also calculating the same error. So you can see that in the output, you can see this root mean square error, this is 13.7. So it was not predicting the strength correctly. It is, the error is too much, and here the error is 5.3, so it is less. Fine. Now this is the visualization part. Like, we are just plotting the graph to just understand the errors, or understand what is the what was the predicted value and what was the actual value. So this is the plot, scatter plot, that we have plotted here. So you can see here you here you can see that I have plotted this line so that you understand. See, when this predicted strength and the actual strength is same, then we'll get a straight this diagonal line, right? But you can see these dots that we are getting are close to the line, so the difference is not much. Only one or two outliers we are getting here, but majorly this model is predicting the values correctly, like near to the actual value only. Okay. So I hope you understood this scatter plot, how it is just showing the relationship between the predicted value and the actual value of the strength. Okay. And then to just make you understand that how these features or the input columns, they play a important role in this machine learning training the model. I have brought this code wherein it is plotting this plot, and it is showing the importance of every feature in when the model was trained. Okay, so you can see that the cement and water, these two features have the role of water and cement is there, but you can see that this fly ash that we have, the column that we have, it also has some impact on the, when the model is trained. So we cannot just say that the strength of the concrete only depends on water, but it also depends on the other things. So these are this basically shows that how important that particular column or that particular feature is when the model is trained. So I hope this you have understood concrete strength prediction. Now, what we'll do is we'll take one more example. We'll move on to another example. So before that, all of you, I mean, you tell me. So now, did you understand that the only the water and the cement ratio, this is not sufficient, right? We need other features also, and then it will we can calculate the strength with when we use other features. Fine. Now let us move to another case study, another example, which is this bridge monitoring. Okay, so let us move to bridge monitoring. Just a second, I need to, my battery is low. I'll just hold on just a second. Yes, sorry for that interruption. So let us look at this example, that is bridge monitoring using sensor and machine learning. So what is the problem? So we have traffic loads in the bridges, right? We have environmental effects. We have aging also. And what is the risk? Risk is the damage, the hidden damage that we cannot see, right? So what are the traditional approaches to this? So we have visual inspections. So manually some people go and they just check that everything is correct or not. There are manual testing that they do. Then periodic monitoring is there for the bridges. Now what is the limitations here? Limitations are some human errors, right? Late detection, and it may not be continuous, right? So these are different limitations when we use these manual methods. So if we don't have any sensors in the bridge, and if the people are personally checking the bridge, then we have a lot of limitations. Then how we can make the bridge as smart bridge? So what we can do is we can add sensors. Okay, install sensors in the bridge. So these are some sensors that we can install. And these sensors, they give us the data. So if we want to use machine learning, so these sensors will be used for gathering the data. And what type of data this sensors will generate is the vibration data that we can get, strain signals, temperature data, so such type of signals that we can get from the sensors. And this is, an example where it shows what is a healthy signal and what is a damaged signal, right? Irregular signal. So here you can see there is many noise here, okay, in the data, in the input data, and this data is quite smooth. Fine. Now, again, the role of machine learning here, we have data, we train the model, and the model predicts, right? So it will just predict and give you, the alarm that there is something wrong or in the bridge, and you should go and check it. So the machine learning learns patterns, it detects anomalies, and it predicts the damage. Now, the machine learning task, we can use it for damage detection, for damage location. So it will just for damage detection, it can give yes or no, right? If we can also detect the damage severity, okay? So this is just a comparison between the traditional approach and the ML based approach that we can have. So in traditional approach, it is obviously manual, and ML is automatic. In traditional approach, it is periodic. So there may be, once in a 6 months or once in 2 months, these tests, manual tests can be carried out. But when we use sensors and ML, then it is continuously monitoring, right? So if you use traditional approach, then the damage is detected, the detection is very late. And since ML is continuously monitors, so we can detect the damages early. So basically we can implement this real time alarm system which continuously monitors, right, and it prevents the failures. Right, so what happens if we use machine learning? So bridges don't fall suddenly, they give signals first. So bridge itself will give signal from the sensors and the machine learning algorithms that we have used that there's something wrong, and it won't fall all of a sudden, right? Now just we'll go through the Python code. So this is again a example where we implement machine learning. Here what we are doing is we are not taking the data from somewhere, we are generating the data. Okay, so these are the input library files that we are importing, and we are generating synthetic data. Okay, so this is not actual data, that is why we call it as synthetic data. So what we are doing is we are generating the signals. Okay, so using this function. So see, this signal is basically a time series, we have time. So we this arrange, this will basically give you the values from 0 to 199. And what we are doing is we are generating sine waves. Fine. And this will give you a normal distribution. So this 0 is basically the mean value, and this 0.2 is the standard deviation that we want. And how many values we want this, 0 to 200. So 200 values means 100 this side of 0 and 100 this side. So a normal distribution we want, this type of signal we want, right? Usually when we want to check the health of the bridge, the data that we get from the sensor is like a sine wave only, and that is why we are also generating the synthetic data using this sine function. Now what we are doing is we are purposely entering or feeding the anomaly here. So what we are doing is here we are just creating a copy of the original signal that from here that we had generated. And what we are doing, since we had data from 0 to 199, between 120 and 140 we are just inserting some anomaly, means we are uh, inserting some disturbance, some distorted signal we are giving here. Okay, because if the signal is distorted, that itself means that there's some problem uh, in the bridge, right? So this distortion we are also inserting, so that the bridge learns that this is the distortion and the remaining signal is the normal signal. Because this we are using unsupervised learning here. So as we are not just giving input to the machine that this signal is the correct signal, this is the distortion, and this causes some problem, so like that we used in supervised learning, that we are not doing here. We are just giving a signal as input to the machine, wherein that signal, major part of the signal is correct or it's smooth, and we are inserting some distortion in this particular part of the signal. And so see, this is the plot of the signal that is generated. So you can see this is the distortion that we have added. So this was the signal that was generated, and this is the distorted signal. Fine. Now what we are doing here is this was the input part that we have created the synthetic data here. And now here we need to reshape the data, because we need to give it as input to the machine learning model for training. So we are just changing the size of the data, and then we are using this isolation forest model, and then we are asking it to train. Fine, so it will train. So here you can see that in the previous example, in this concrete strength prediction, where we were using the regression model, you can see that while we asked the model to fit, we were giving two parameters. We were giving the features as well as the prediction value y. So we were giving the class also, that means the strength also, right? But here, since we are using unsupervised learning, we are only giving this one x, the signal, as input and asking it to learn, and then we are predicting. Okay, so here you can see that this -1 means there's a problem, and 1 means it is normal. Now here we are just plotting the graph after the predicted, what you can say, the predictions of the machine after we have trained and we have asked it to predict, that we are plotting it here. And you can see that it has predicted this anomaly here. So it is, the machine learning has predicted that there is a possible damage. Okay, because the signal is distorted here. Okay, so it has very well learned that these are the normal waveforms, and there is some distortion in this part. Okay, so this was just a very small example for you to just understand how we can use machine learning for prediction. So this was the second example that I had brought today. So let us move on with our original slides. Now, what are the future scopes here? We can have smart cities because we are using AI ML. We can have sensors everywhere. We can we have smart cities and digital twins. Now, what is digital twins? This is a concept where what we do is like we create a model of the original model. So the original model, suppose if I talk about smart grids, if you know, or the entire structure, if I talk about civil engineering. So if I we have a very big structure, a very big bridge, okay, so what we do is we just create a model of that bridge. We In the software itself we simulate that bridge, and we add sensors to it, and then we check that what will happen if we apply the same thing to the actual bridge. Okay, so that is the concept of digital twins. So digital twins, the name itself gives you the meaning that it is just a replica of the original model, and we just use that model. So it gives us the feeling of like what will actually happen if we use if we use this machine learning or this whatever we have implemented in the real world, what will happen. So this is digital twin, and this is the market trend that is going on. Various researches are going on in this digital twins. There are various applications where this digital twins can be used. In this structural engineering you can use, even in smart grids also we can use. Okay, then AI based monitoring will be there everywhere. So that's it from my side. I hope I have made you understand how you can use machine learning in structural engineering. And if you want, I can also share with you the codes that I had showed you and I had explained. So you can also use it. You can try out different machine learning models. You can check the output. So that's it from my side.
Thank you, ma'am. Thank you so much for your insightful. Thank you, ma'am. Any questions from the participants?
Yes, madam.
Yes, sir. Please.
May I go ahead, madam?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. Very nice presentation, Professor Kushbu.
Thank you.
I have two questions. One is basically when you're talking about the strength of the concrete, you are talking about the weightages, right? Water cement ratio, fly ash, and things like that. Was the weight, and you also showed there was the water cement ratio was the highest weightage it was having. I mean, is that was an input or the model learned it?
Sir, water cement ratio is the input that we are giving to the machine learning. You're talking about the traditional method that we have seen, right?
No, madam. What I am trying to ask is
Yes.
weightage. You told no, madam. There was a more weightage for the water cement ratio. That graph you showed, no, I don't remember
Yes, yes,
that
yes, yes.
number.
The feature importance of the feature.
Feature importance.
Yes,
That
yes, yes.
feature importance, was it
Hmm.
an input or the machine learned it? If it has a
No,
learned
no.
it, how it
Huh.
has learned it?
No, no, sir. It is the input that we have given, but this the graph that I had showed, it basically shows that which feature was most important for the machine to learn to predict the output. So water cement ratio was very important that we have seen, but I'll just again share my screen so that I can explain it. Yeah, this I think you're talking about, right?
Yes,
Yes.
yes,
So
yes.
here what we had done is this is the basically the function that we are calling here. We are basically asking the model, or we are just checking that which are these were the input features. Okay, the strength was the predicted value. So these were the inputs, and here we are just checking that how important a particular column or the particular feature was when the machine was trained. Okay, so this water to cement ratio and age, this you can see it plays a very important role. right? But here we could see that other features were also giving some addition to for calculating the strength of the concrete. So this was that. I hope I have answered your question.
Yeah, this I could understand in a presentation only, madam. My question is this importance of the weightage you give. No, I heard you told weightage also.
Hmm, hmm, hmm.
Weightage given, was it an, I'm repeatedly asking, was it an
Huh.
user input or it is
No,
machine learned?
no, it is not input. Like we are not telling the machine that this is important. we
Okay,
are just we are just giving this as input. These numbers, these figures we are giving as input. So
okay,
it has learned that, okay, the water to cement ratio, what is the relationship with the output, the predicted strength. So this is what the machine has learned, that these are the important features. We are not giving anything as input like this.
okay. If I understand correctly, that
Yes,
the column and the matrix that you gave, that was the input,
correct.
and machine learned that WC ratio is having a way more weightage than
Yes,
you consider the fly ash.
yes, yes.
Now, my question is, how it did learn, madam?
Sir, there are different functions or different in machine learning. uh, Previously what used to happen is we used to use many different models, it used to predict. But now we need to also, we have understood that we need to check, okay, which feature played a very important role. So there are various different methods, like we have sharp, we have lime. These are different methods which basically check. They have some internal mathematical models inside them, that they check which columns, or some mathematical thing, that from there they it